In this video, we're going to be looking at the blackbody spectrum. A couple of features here. We have a graph that tells you how much light we have, intensity, as a function of wavelength. The visible wavelengths are obviously down here in the rainbow section. We have a thermometer which tells us where we are in the great world of temperature, and a slider that allows us to adjust the temperature. And up here is a kind of idea of what color this would look like if you could see it. So for example, if I decrease the temperature such that I am at a standard light bulb, it's kind of this reddish orange. This is a standard incandescent light bulb. That does tend to be more yellowish in color, not pure white. What you can see if I increase the temperature back up and decrease it is that the shape of the curve, the general shape of the curve, stays more or less the same. It goes down in the UV, it goes down in the IR, and then it has a peak somewhere in the middle. And the location of that peak, the wavelength that that peak actually is at, shifts further and further into the blue as the temperature is increased. So we are now right about at the temperature of the sun. Notice the temperature here is in Kelvin, and it looks fairly white, which is, it's the sun. It gives us white light. That's what it does. Right? If I keep increasing the temperature, we might want to change our scale here a little bit. You can see it shifts further and further into the blue. And conversely, if I go back to the red, it shifts, or if I go down in temperature, it shifts back to the red. Down here we have the temperature of your oven. This is obviously outside the visible. It's in the infrared. It feels warm to us. We sense infrared radiation because that's what we think of as heat.